Hi everyone, welcome back to the channel. In this tutorial, we'll walk through creating a sleek graph design using the HUD and UI Elements add-on for Blender. Let's dive right in and bring this concept to life. We'll start by crafting the frame for our graph. Let's add a rectangle and expand the HUD and UI Elements panel. From here, we'll set the width and length to 0.26, adjust the inner thickness to 0, and set the outer thickness to 0.0005. This creates a clean, minimal frame to house our data. Next, let's add horizontal subdivision lines. We'll do this by creating a matrix of rectangles. Under matrix of rectangles parameters, we'll set number of elements x to 1, number of elements y to 14, and adjust spacing y to 0.26 divided by 15. For the base element, we'll set width to 0.26, length to 0.0005, and activate the Fill checkbox. This gives us thin horizontal lines spanning the frame. To create vertical lines, we'll duplicate this element. Let's set number of elements x to 4, number of elements y to 1, adjust spacing x to 0.26 divided by 5, and swap the width and length values under base parameters. And just like that, we have a fully structured grid. Now let's bring the graph to life with some data lines. We will start by creating a Perlin noise object. To ensure it fits within the frame, we'll set its length to 0.26. To visualize the base curve more clearly, let's set y scale to 0 temporarily. Under function parameters, we'll choose the cubic function. Then adjust the parameters as follows: a to negative 44.15, b to negative 6.5, c to 0.27, d to 0.082, and x values offset to negative 0.12. For added details, let's set scale to 0.08, subdivisions to 512, and adjust the precision under noise parameters to 5. To create a second line, we will start by creating a new Perlin noise object. Just like before, we'll set the length to 0.26 and flatten the line by reducing the y scale to 0. Then, we'll adjust the function parameters by setting a to 0.5 and b to negative 0.93. Next, we'll bring the subdivisions up to 256 and set the y scale to 0.163. To keep the line within bounds, we'll set the y lower limit to negative 0.26 divided by 2 and the y upper limit to 0.26 divided by 2. For some added variability, we'll tweak the noise parameters by setting position x to 13.9, position y to 6.3, delta to 3.5, and precision to 5. That wraps up the data lines. Feel free to experiment with the values to suit your specific needs or to explore different visual effects. Let's move on to creating the indices. We'll start by creating a matrix of text element. Once we have it in place, we'll set the number of elements x to 1, and the number of elements y to 14. To ensure everything is evenly spaced, we'll set the spacing y to 0.26 divided by 15. Next, we'll refine the text appearance. Under the base parameters, let's set the size to 0.005. Then, we'll align the text to the right and fine-tune its position so it sits neatly alongside the graph. We'll then change the distribution to random numbers. Set the count to 2. The decimal count to 0, and uncheck the Add Leading Zeros checkbox for a cleaner look. Finally, we'll set the start offset to 1, unit spacing to 1, and seed to 0. With our first set of indices ready, we'll duplicate the text object. This time, we'll align it to the left and adjust its position. We'll also modify the settings slightly by increasing the count to 3, setting the start offset to 100, and unit spacing to 100. To complete the indices, we'll add one more variation. Let's duplicate the text object again, but this time, we'll replace the text content with t plus 1 space, t plus 2 space, t plus 3 space, t plus 4. Then we'll change the distribution to words from input and align the text to the center. Under the matrix of text parameters, we'll adjust the number of elements x to 4 and the number of elements y to 1. Making this row of text span horizontal. To ensure proper spacing, we'll set spacing x to 0.26 divided by 5 and tweak the object's position so it sits exactly where we want it. To complete our design, we'll create a legend that provides context and explanation for the elements in our graph. Let's start by adding a text object to act as the foundation for the legend. We'll align this text horizontally to the left, then set its size to 0.01. Next, we'll adjust its position to ensure it fits neatly into the layout, and we'll give it a slight Z rotation of 90 degrees. With that done, we'll clone this text object 3 times so we can define multiple labels. For our first label, let's set the text to read undefined initial time. Moving to the second clone, we'll update the text to module performance. Finally, for the third clone, we'll label it module errors % to round out the legend with a focus on error tracking. Now, we'll duplicate the first text object once again, but this time, we'll modify it to represent a key symbol. We'll set the text to T, set Z rotation to 0, align it horizontally to the center, adjust its size to 0.025 to make it slightly larger, and adjust its position. Next, we'll duplicate the main frame to add a visual line symbol. We'll carefully adjust its position so it sits just right within the legend area. Let's also set its width to 0.02 and its length to 0.002 to ensure it's proportional. We'll then activate the Fill checkbox, creating a solid appearance. Finally, we'll clone the object and position it under the next text element. Once everything is in place, we'll fine-tune the global positioning of the entire cluster. And there we have it, a graph built with HUD and UI elements in Blender. If you haven't already, be sure to subscribe and hit the notification bell so you won't miss any of our future tutorials. If you have any questions or ideas, feel free to leave them in the comments below. We're always happy to help. Thank you so much for watching.